Hi, today we're going to talk about theoretical probability. So, if a sample space has n outcomes which are equally likely to occur when the experiment is performed one time, then each outcome is going to have the equal chance of occurring, which is going to be 1/n. So, when the outcomes of an experiment are equally likely, the probability that event A is going to occur is going to be denoted by the number of times that event A happens divided by the total number of outcomes that could possibly happen in the universal set. So, example number one, it says a ticket is randomly selected from a basket containing 6 red, 13 blue, and 9 yellow tickets. Determine the probability of getting a yellow ticket. Well, we know we have 9 yellow tickets, but we have a total of 6, 13, and 9 tickets, which will give us 28 of them. So the probability that you're going to choose a yellow ticket is going to be 9 out of 28. Example number 2, it says an ordinary 6-sided die is rolled one time. Determine the chance of not getting a 2 or 5. So basically, you want to roll any number on that 6-sided die except for a 2 and a 5. So that means there are 4 other sides that you can roll. So that is going to be 4 out of 6, or if you want to reduce it, it's going to reduce to 2 over 3. Example number 3, it says use a 2-dimensional grid to illustrate the sample space for spinning a 3-sided spinner and rolling a 4-sided die simultaneously. Find the probability of spinning a 2 and rolling a 3. So before we can even do that, we need to draw us a grid. And remember, your grid is going to be dealing with the different outcomes. So we can have a spinner, and then we can have a die that we are going to roll. So you can either spin a 1, a 2, or a 3, or you can roll a 1, a 2, a 3, or a 4. So there are going to be 12 total outcomes denoted by these circles, which tells you how you can spin and how you can roll. All right. So if I were to spin a 2 and roll a 3 at the same time, remember the word simultaneous means at the same exact time. So a spinner in one hand, a die in the other hand, and I'm going to spin and roll at the same time. The probability that I'm going to get a 2 and a 3 on the same spin and roll, so that means spin a 2, roll a 3, there is only one way I can do that. So that would be a probability of 1 out of 12. Okay. The next one, it says that we want to find the probability of spinning a 1. And sorry, I had to make a correction. Or rolling a 2. So I can either spin a 1 or roll a 2. So if that is the case, if I spin a 1, I have 3 ways that I could spin a 1, because I could spin a 1 and roll any number. Or it says I need to roll a 2. So as long as I roll a 2, I have a total of 1, 2, 3, 4, 5, 6. 6 ways. So I have 6 out of 12 here, which will give me 1/2. So as long as I spin a 1, or as long as I roll a 2. So I basically circled in my diagram all of the possibilities that would give me that, and I will see I will have 1/2. All right. Let's look at example 4. It says, illustrate the possible results when 2 4-sided die are rolled and the scores are combined. Find the probability that the sum of the die is going to be 6. So here, if I write me a grid to help me visualize things, I'm rolling two four-sided die. So I can either roll a 1, 2, 3, or 4. Same thing for the other die. So I'm gonna have here that this is gonna be die 1. This is gonna be die 2. All right. So it says that the scores are going to be combined, which means I'm going to add them. So if I roll two ones, my total score is going to be a 2. If I roll for die 1, if I roll a 2 and then a 1 for die 2, then that's going to give me a total of 3. If I roll a 3 for die 1 and a 1 for die 2, that's going to give me a total of 4. And then here I'm going to have a total of 5. If I go to rolling a 2 for die 2, that's going to give me a 3, a 4, a 5, and a 6. If I roll a 3 on die 2, that's going to give me a sum of 4, 5, 6, 7. And if I roll a 4 on die 2, that's going to give me a sum of 5, 6, 7, and 8. So I put my sums in the middle. So it says find the probability that the sum of the die is going to be 6. So the probability that I'm going to get a 6 is here. So that is going to be a 3 out of 16 total possibilities. All right, so let's look at number 5. There are 34 students at a party. 14 students say that they only like butter pecan ice cream, and 9 students say they only like cookies and cream ice cream. 6 students do not like either. Display this information on a Venn diagram and then use the Venn diagram to find the following probabilities. So if I were to draw a Venn diagram here, we draw a box for our universal set. We have butter pecan and cookies and cream. So it says 14 students say that they only like butter pecan. So that means I have 14 in the portion of the butter pecan circle that's not in the intersection. And then it says that 9 students say that they only like cookies and cream. So that is going to be a 9 in the cookies and cream section that is not overlapping. Then they said that 6 students do not like either. So the 6 students will go on the outside. So here, if I add them up, I have a total of 29 students in this Venn diagram, but they say that there are 34 students at a party, which means that if I subtract 34 and 29, I would end up with 5. Okay, because when I add them all up, I get a total of 34. So right here where it says the U, I'm going to put in parentheses that this is going to be 34 total. Just to make you remember that there are 34 elements on the inside. So we want to find the probability for part A, which is that they like cookies and cream, but not butter pecan. Okay, so the ones that like cookies and cream, but not butter pecan, that's going to be a probability of 9 out of 34. The probability that they're only going to like one flavor, that's going to be the butter pecan, which is 14, and the cookies and cream, which is 9. So 14 plus 9 out of the total amount of people, which is 34, that is going to simplify to 23 out of 34. we want to find a probability that they like both flavors. So the students who like both flavors are in the intersection, which is 5. So that's going to be 5 out of 34. And then D says the probability that the students are going to like at least one of the flavors. That means one or more of the flavors. So these 14 students like one flavor. These 9 students like one flavor, and then the 5 in the middle like both of them. So that means at least one. So when I add up all of those, I'm going to have 14 plus 5 plus 9 out of a total of 34. And that is going to simplify and give me 28 over 34. And then, of course, if you want to, you could simplify it. It does not matter. So 28 and 34 can both be divided by 2, which would end up giving me 14 over 17. Either or. It does not matter if you simplify the fraction or not. IB really does not care about that. All right, and last but not least, part E, you want to find the probability that the student that's randomly picked does not like neither flavor. So there are 6 students who did not like either flavor. So that's going to be 6 out of 34, which simplifies to 3 over 17. Remember, it does not matter which fraction you use. IB does not care about if it's simplified or not, as long as they are equivalent. All right, so if you have a question, please ask me or your teacher, and you have a great day.